Okay, hello again, YouTube. I'm revisiting the MFJ-929 Antenna Tuner that I installed in my previous video. Just checking a couple of options. One feature I was most interested in is the meter's ability to check my power output and also the antenna's SWR without being matched. I just want to check the antenna's SWR, what it's naturally resonant at, so I know if I can make adjustments without having to pull out all my equipment and plug in an actual SWR meter. And so far I wanted to show you how I'm able to do that. This tune button, as I showed in the previous video, is a little sticky, but I wanted to show you how it works. So right now, if I press the tune button for about a second or two and release it, it'll tune the antenna. I can also, of course, do this from the 706. And then, of course, if I transmit, I have it on relatively low power in FM mode. So if I transmit, it shows me it's transmitting about 24 watts, 1.2 SWR, 0.4 watts reflected. Now that's tuned. If I press the tune button quickly, it bypasses the tuner, and now when I transmit, it shows me the antenna's actual SWR is 1.7. Now, I checked with my not-so-trusty SARC 100 antenna SWR analyzer, and it indicated that my 20-meter ham stick seems to be resonant at 14-420 megahertz, 14-420. So I wanted to see if that's true. So it looks like it's resonant around somewhere probably around 14-250. Interesting. With a 1.6 SWR. Well, that seems to be the best I'm going to be able to do now. 1.5 to 1 at about 14-275. It might fluctuate to 1.4, I don't know. Things can be variable. But I'll call that very acceptable. And of course, if I decide to tune it, they can tune it to 1.0. All right, now I'm going to match my 40-meter ham stick first with my antenna matcher, and then I'll verify its resonant frequency. Okay, I now have my 40-meter ham stick attached. Although we've already kind of proven that this SWR analyzer is questionable at best in accuracy, I'm going to go ahead and run a scan. And that's pretty much what I sort of expected. The antenna length has been determined by my attempt to put a capacitor across the terminals on the antenna itself. So I'm going to go ahead and add some capacitance with my matcher and see where we're at in resonance. I'm sorry, still in 20-meter mode. 7.210 seems to be the resonant spot, roughly. So I'm going to go ahead and add 30 picofarads, 62 picofarads, 120 picofarads, surprising. That's 180 picofarads, 240 picofarads. This is not what I expected here at all. Interesting. Let me go back down to where I thought it would be, 360 picofarads, and run a scan. This is odd, but I suspect adding capacitance has electronically lengthened the antenna. So our resonant point is somewhere below where it should be. Okay, that's more like it. Okay, so this is telling us a little different story. I am a little low in frequency, 7.125 megahertz, but I'm getting a nice 1.0 to 1 SWR, even at 27 watts. So I really need to shorten the antenna, because this is a little below where I want to operate, and we just don't have that much bandwidth at 40 meters. Okay, that's where I'm at right now, and 7.230, I can go up to about 7.26, maybe 7.265 before I really must use the tuner. You know, it hits about 1.8, 1.9. So I think I'm gonna stick with this. But this is really the main feature that I wanted, and really why I bought this tuner, and so far it's worked out really well. Obviously, the LDG Z-100plus doesn't offer this. Some LDG tuners do. I do notice this MFJ-929 does tune quite a bit quicker. Whether it's a memory tune or it's using its IntelliTune, I can't really tell. It can tune probably 3 times faster, in my opinion, than the LDG tuner can tune at its fastest. So when I do a quick tune on 14 megahertz at 20 meters, it tunes incredibly quickly, and that's really nice. I hope this has been helpful. I'll probably do some more videos on this tuner as I learn more of its features if necessary. And if you have any questions, please comment in the comment section. I'll say 7-3. Thanks for watching.